In this series, we're going to show you how to draw something with CNC Stylus and SmartBench. For this project, we decided to create a sign mounting guide. This is going to give us an outline to align our sign and some mounting holes for our standoffs. We're going to take you through this guide step by step. First of all, by creating our file using Vectric and creating our toolpaths. We're then going to take you through transferring the file to SmartBench. We'll then show you step by step on how to use CNC Stylus and different types of pens, loading Stylus into SmartBench. We're then going to focus on SmartBench operation for a job, such as setting a Z datum when using Stylus, setting your XY datum, and starting the job through to doing a tool change. And at the end of the series, we'll have a finished sign mounting guide. There are a number of different ways to follow us through this tutorial. You can either watch our YouTube videos, or you can go to our knowledge base, where we're broken down into small bite-sized chunks. We show you videos for each article with written stages, and we link to any resources you may need within the knowledge base. Whichever way works for you best, let's get started. This tutorial will be split into two sections. Part 1 will focus on file generation, and Part 2 will focus on SmartBench operation. Before we can cut files, we need to do the design work in some CAD/CAM software. The CAD/CAM software will then export the toolpaths for SmartBench. If you want to skip ahead to Part 2, you can simply download the files we'll use from our knowledge base. Click the link in the description below to go there. So for Part 1, file generation. For this tutorial, we'll use Vectric VCarve Pro for our CAD/CAM software. Vectric works by defining a general job setup, drawing out basic features in 2D, assigning toolpaths to the drawn features, exporting the toolpaths to a file. Let's get into it. The first thing we're going to do is define a job setup. This article is the first step of the CNC Stylus drawing tutorial. Start by creating a new file by clicking on the Create a New File link here. We're now going to select the job type. For this job, we're going to use single-sided. We can now enter in our job size. We're going to enter in 1200 as our width in the x-axis, which is this axis here. And we will enter 600 into the y-axis, which is the axis going up and down the screen here. We can then set our thickness to 0.1 millimeters, and we're using millimeters as the unit. We're going to set the Z0 position here to material surface, and we will ensure we use this datum later on when we set up our job on SmartBench. Our XY datum is going to be set to the bottom left-hand corner. For reference, this is the corner closest to the SmartBench console. We're going to choose standard modeling resolution, and we're going to keep the appearance as birch. We can now press OK. This is the second step of the CNC Stylus drawing tutorial. We have now created our job setup, so we need to draw our text. We'll click on Create the Text using the same font and size as we did before. We can type in this box Unit 12. We can now select our text type, which is Arial Black. Text alignment can be set to center, and we can type in our text height of 200. We can now press close, and the text will appear in the drawing window. To center our text into job, we need to first highlight the text, which will turn magenta. We can then go to Edit, Align Selected Objects, and Center in Material. This will center the text to our job. We're now going to add the secondary text. Click on the text tool again. We will type in this box this way, and then press Enter to move the word up to the next line. Select Arial Black. Text alignment is center, and our text height this time will be 25 millimeters. We can now press Close. We can now center our text to material just as we did before. Click in the text, Edit, Align Selected Objects, and center in material. We can now move the text down by selecting the text and using the arrow keys on our keyboard. We now need to create the arrow. For this, we will choose the rectangle tool. We can select the corners to be square. The width for this will be 20 millimeters in the X, and the height for this will be 40 millimeters in Y. Pressing close will then add our rectangle to the drawing. We can now select our rectangle, click Edit, Align Selected Objects, and select Center horizontally in material. We can again select the object and use the arrow keys to move our rectangle. We now need to draw a polygon. Select the Draw Polygon tool, select the number of sides as 3. We can now dimension this using a radius of 20 millimeters. You can see here that the side length will adjust. For this, we will choose 25 millimeters, and this will add our triangle to the drawing window. We can now select the triangle, click Edit, Align Selected Objects, align this to center of the material, and again use our arrow keys to move the triangle down. We now need to join these selected vectors. We can click the Trim Vector tool and remove these two lines. Press close. You can now see that this is one individual vector rather than being two shapes. We now need to draw the circles for our mounting holes. We click the Select Circle Drawing tool, enter in a dimension of 19 millimeters, and we can now drag our circle into position. We're going to repeat this for the 19 circles we've created by using Ctrl-C and Ctrl-V. And we can click on these and drag them into position. Now we're going to add a tool to the Vectric tool database. In order to create a toolpath in Vectric, you need to provide the software with information about the tool used. Vectric already has a database of tools where you can store setup information about cutters used in your jobs. In this instance, we're going to create a pen for pen plotting. To add a tool to the database, we're going to show you first how you add a tool through toolpath setup. When setting up a toolpath in Vectric, you'll need to select a tool. In this example, we'll be using a profile toolpath setup. Go to Toolpaths and click on Profile Toolpath. We can now press Select under Tool. This will open the tool database window. You can see here tools are listed in the category of material. We're going to click on this button here to create a new category and press the plus icon. In here we're going to type in pen plotting, press Apply and OK. And you can now see we've created a new category. If we click on pen plotting and click on metric tools, we can now create a new group by pressing Add a Group, and we can call this group Pens. Click in the notes box and then press Apply, and we can see the new group has been created. Now we're in this group, we can now add a tool. In this instance, there is not a tool type for a pen, so we're going to select end mill. We're going to create this in units of millimeters as 0.5 millimeters diameter, number of flutes as 1. If we then click Apply, you can then see the tool has then been created under our group of pens. If you click Create Settings, you can now add specific settings for that tool within that group. In this instance, we only need to change two numbers here, which is the feed rate to 6,000 millimeters a minute and the plunge rate to 750 millimeters a minute. We can now press OK. You can now see that our tool has been selected. The second way to create a tool is to go to Toolpaths in the menu, Tool Database, and you'll see exact same windows you saw before. Follow the previous steps to create a new material group, a tool group, and a tool. Now that we have created our drawing and created a tool, we will need to create toolpaths from the drawn features. For this tutorial, we'll be using our 0.5mm tool. To draw the first toolpath using a biro, we'll select the profile toolpath. We'll first select our drawing by clicking on the outline, and if we hold Shift, we can then select multiple objects. So we'll select our text and the arrow. We can then click Toolpaths in the top right and select Profile Toolpath. We can then enter our start depth, which will be 0mm, and our cut depth, which will be 0.1mm. We can then select our tool, which we've created earlier. Here we have our end mill 0.5mm, and press Select. Machining vectors need to be set to outside or right. And now we can press calculate. This will then show our toolpath in the 3D view. To go back to our previous screen, we can use 2D view tab at the top. We now need to create a toolpath using our Sharpie pen, which we'll do in exactly the same way. We first need to select our circular vectors. Again, holding shift between clicks will allow us to select multiple vectors. We can now click Toolpaths, Profile Toolpath, and use exactly the same settings as we did before. Press Calculate, and this will now create our toolpath for the circles using a Sharpie pen. You can click the ticks next to the toolpaths to display each toolpath, and we can view these in 2D or 3D view. Now that we have created our toolpaths, we need to export them as a GCode file for SmartBench to run. Our toolpaths are located here, named Profile 1 and Profile 2. And you can deselect them or select them by clicking the tick. We're now going to click Save Toolpath. We're going to save the selected toolpath, which we can see is highlighted as Profile 1. We're going to choose a post-processor of Yeti Tool SmartBench and press Save Toolpath. And we can now save this to our desired location. I'm saving ours as Unit 12 Stylus Drawing -Biro. I'm overwriting a previous file here. We can now select Profile number 2, and you can see that this will change under the toolpaths to be saved, so we don't need to go back out. We can now click Save Toolpath again and save this as Unit 12 Stylus Drawing Sharpie. We can replace my existing file. Our files are now ready to be transferred to SmartBench. What drawing tools can you use with CNC Stylus? CNC Stylus can accept a wide range of pens and pencils as long as they are no larger than 16mm in diameter. We would suggest you do not use metal-tipped fountain pens as the nib could break through the paper. As you're already aware, pens do not last forever, so if you're doing a large project, we'd recommend you have a lot of spares so you can swap those out during the job. How do I load a pen into CNC Stylus? You will first need to select the correct size collet for the tool you're using. We have created a quick ClickUp table which can be found on our knowledge base. The nut, which features an eccentric washer, requires the collet to be fitted from a specific side. Here you can see the thinner part of the washer at the top and the thicker part of the washer at the bottom. Holding your nut with the thicker part at the bottom and the thinner part at the top, insert your collet and push up until it clicks into place, and then push down to release. If you've fitted the collet correctly, you should be able to invert the nut and the collet will hold in place. Next, we can pre-fit our nut and collet to the stylus. This is now ready to accept our pen. We can now insert our pen into the stylus, ensuring that we are holding our pen at the lowest point to reduce wobble. If you are expecting a tool change during a job, you will need to consider the position of your pen now so that your pen will extend the same distance from the collet. The easiest way to do this is to measure up against a feature of SmartBench. We would recommend using the bench feature here. How do I choose the correct scoreboard for drawing with CNC Stylus? When drawing with CNC Stylus, we need to ensure we use something rigid and flat. We would recommend using a 12mm double melamine faced MDF board. This is to ensure we have a smooth surface to draw on and a smooth surface for our lower wheels to roll along. How do you hold paper down to draw on? There are many different ways to hold paper down to draw on. We would recommend using something such as a low-tack tape. We need to ensure our paper is flat and does not lift. So we're first going to cut our paper to the size of our job. For example, this is a roll of paper which comes in various different lengths. This is a slightly thicker paper, so this is around 60 grams per square metre, so much thicker than your normal office printer paper, which makes it good for large format drawing. So to cut this to size, we're going to use a straight edge. So I'm measuring this just larger than our job so that I have enough room to tape along the edges. So we're trying to keep the paper as tight as possible, ensuring we lay a strip of tape right along the edge, ensuring that there's no air as well trapped under the paper so it stays flat. So we've now taped down our paper, which is nice and flat. Another alternative to tape would be using a spray mount adhesive, which we found can be really effective, but depending on which material you're using, depends on how easy that is to clean off the residue afterwards. When using the CNC Stylus, we need to ensure the wheels on our upper beam do not roll along the material surface, as this can cause creasing and tearing. To do this, we'd actually recommend using a gauge, something like a piece of material, to ensure our wheels are set a fixed distance above the paper. So as you can see, from using our material as a gauge, we now have a fixed gap between the wheels and our paper, and this is consistent from this wheel on one side straight across to the wheel on the other side. So now we can tell our beam is nice and flat. One important thing is to ensure our clamp handles are tightly secured so that our beam cannot move up and down while we're drawing. We're now going to load CNC Stylus into SmartBench. Using the loop, we're going to lower the stylus into the Z head and ensure the boss sits securely and flat into the collar. We're now going to use our 6mm driver to tighten our hex bolt. We're now going to tighten the hex bolt until we start to feel resistance and then continue to turn for a quarter of a turn. This needs no more than 5 Newton-meters of torque. We're now going to set our XY datum on SmartBench. This needs to coincide with our Vectric file we created earlier, which is set to the bottom left corner and operates using the X-axis going in this direction and the Y-axis in this direction. In this case, we're going to use the centre of our tool as the reference point. We're first going to move the Z head towards us and then away from us in the Y-axis. And in this case, we need to remove the dust shoe plug to get a better look. We can now move our Z-axis down so it's closer to the material. In this instance, you can see that we need to move it closer towards us. So I'm going to set our datum at this point here using the manual datum. We're now going to set our Z datum for using CNC Stylus. This is what tells SmartBench where the pen touches the paper. Unfortunately, because the pen is made from plastic and is not a conductor, we need to set this manually rather than using the Z probe plate. To set the Z datum manually, we're going to move the Z axis down very slowly until the pen touches the paper. As soon as the pen touches the paper, we're going to switch to move the axis in 1mm increments. And we're going to move down by an extra 2mm by pressing the down arrow twice. This will take up any movement in the CNC Stylus to allow our constant pressure system to work effectively. We can now press the set button and the light will flash green to say it's remembered our setting. We're now going to start our job on SmartBench, which we transferred over earlier. We're going to first select the file. In this case, it's called Unit 12 Stylus Drawing Biro, and press the tick. This is now going to load our job and check the job for errors. We're now going to load our file, which we transferred to SmartBench earlier. Clicking the File Explorer, we can now click on our file, which is called Unit 12 Stylus Drawing -biro.gcode, and click the tick to load the file. We'll now be asked if we would like to check the file for errors, and we're going to press yes. This is now going to check the file for any inaccuracies in our G-code. In this case, our file is good to go, so we can press finish. We'll now be shown a small visualization of the first 1,000 lines of G-code. We can now press play. We'll now be asked if our Z-axis should lift away from the job if it was to pause. In this instance, we can press yes. We can now accept the safety instructions, and we can start our job by pressing go. Okay, so SmartBench has finished our first file. We can now swap out our pen to run our second file for the mounting holes. Now we're going to reload our second job file. We need to remember we need to now reset the Z datum for our new pen. We're now going to run our second job using the same XY datum. And off it goes. So we've now finished our job, which used two different types of pens to create our sign fitting guide. And that's just showing you one of the examples of a project you can do with CNC Stylus. So that's the end of this tutorial. If there's anything you want to go over again, please check out the specific knowledge base articles relating to CNC Stylus and drawing. Thank you. Here are our top 5 drawing mistakes. The first one, check your pen is working. As you can see here at the start of our job, our pen wasn't running properly. We'd recommend doing a quick scribble to make sure that's working correctly. The next one is measure twice, draw once. As you can see on this job, we went out of our paper boundary. We want to make sure we're always drawing onto the paper and not onto the tape that's holding it down. Our third top tip is to ensure you're not having pen wobble. Push your pen fully into the collet to ensure that there's the smallest distance sticking out from the nut. The fourth biggest mistake is ensuring that your pen touches the surface at all times. 3 things that can affect this are your Z datum, ensuring your beam is level, and ensuring you're using a flat surface to draw onto. And finally, if you're finding your pens running out mid-job, make sure you've got plenty of spares.